We've sent spacecraft to Mercury, Venus, Mars, Jupiter, Saturn. We've spent years studying some of these worlds from orbit. But Uranus, one spacecraft has ever visited. It arrived in 1986, looked around for a few hours, and disappeared into the darkness. Almost everything we know about this world comes from that single encounter, combined with observations from billions of kilometers away. And the more we learn about Uranus, the stranger it becomes. Because this isn't just another planet. It may be the planet that breaks the rules. Start with Earth. Our planet is tilted about 23 degrees. That tilt gives us seasons. Mars is tilted about 25 degrees. Saturn, about 27. The planets aren't perfectly upright, but they're close. Then there's Uranus. Its axis is tilted approximately 97.77 degrees. Uranus doesn't just lean, it rolls. Imagine taking a spinning top and knocking it onto its side. That's roughly what Uranus is doing as it travels around the sun. And the consequences are ridiculous. Uranus takes about 84 Earth years to complete one orbit. So for roughly a quarter of a Uranian year, one pole can face the sun, while the other remains plunged into darkness. 21 years of sunlight, then 21 years of darkness, and then the planet slowly switches sides. But here's the question. What could possibly knock an entire planet onto its side? The early solar system was nothing like the calm neighborhood we see today. Planets were forming. Asteroids were everywhere. Worlds collided. And one leading explanation is that Uranus suffered an impact with something enormous, potentially an object around the size of Earth. One collision may have been enough, or perhaps several impacts gradually pushed Uranus farther and farther over, until eventually it stayed there. But there's a problem. We don't know for sure. We've never drilled into Uranus. We've never placed an orbiter around it. We've never directly studied its interior. We're trying to reconstruct one of the most violent events in the solar system's history from observations, made from a distance, and one spacecraft that flew past almost 40 years ago. And that would already make Uranus strange enough. But then we discovered something even more confusing. Uranus is freezing. Here's something that seems backwards. Uranus can reach temperatures around minus 224 degrees Celsius. That makes its atmosphere colder than Neptune's in some places. And Neptune is farther from the sun. So why? Normally, the farther you travel from the sun, the less sunlight you receive. But giant planets don't only get energy from the sun. They also release heat from inside themselves. Jupiter does it. Saturn does it. Neptune does it. But Uranus gives off remarkably little internal heat. Something appears to be preventing much of that energy from escaping. One possibility is that the ancient collision that tilted Uranus also disrupted its interior. Another possibility is that its interior is layered in a way that traps heat deep inside. But once again, we don't know. And then Uranus does something even stranger. It takes the invisible shield surrounding a planet and seems to break that too. Uranus is different. Its magnetic field is tilted by nearly 60 degrees from its rotation axis. And it isn't even centered on the planet. It's offset by roughly a third of Uranus's radius. Imagine taking Earth's magnetic field, pulling it sideways, tilting it, and then spinning the entire planet underneath it. That's Uranus. As the planet rotates, its strange magnetic field sweeps through space. And behind Uranus, the magnetic field gets twisted into a gigantic corkscrew-like tail. Even its auroras don't behave quite like Earth's. And here's the unsettling part. We didn't even know Uranus had a magnetic field until Voyager 2 arrived. Which brings us to one of the greatest discoveries ever made around this strange planet. And it happened without anyone actually seeing it. In 1977, astronomers were watching Uranus pass in front of a distant star. The planet was supposed to block the star's light. Simple. But then the star disappeared, and reappeared, then disappeared again. And again. 5 times before Uranus even reached the star. And 5 times after. Something was getting in the way. The answer? Rings. Uranus had rings. Not the spectacular bright rings of Saturn. These were narrow, dark, faint structures hiding around the planet. Today we know Uranus has 13 known rings. And the discovery tells you something important about this world. We didn't always see Uranus directly. Sometimes, we had to watch its shadow to discover what was hiding beside it. But the strangest thing Voyager found wasn't even Uranus itself. It was one of its moons. This is Miranda, and at first glance it looks broken. Miranda is only around 470 kilometers across, a tiny moon. Something that small should be relatively simple, old, cratered, quiet. Instead, it looks like someone took several completely different worlds, smashed them together, and glued the pieces back into place. Smooth regions, deep grooves, strange oval formations, massive fractures, terrains that look almost completely unrelated sitting beside one another. Scientists have proposed that Miranda may have been violently disrupted in the past, possibly by an impact or tidal forces, and then partially reassembled. But there's another feature that makes this little moon almost absurd. Verona Rupes, a gigantic cliff face. Some estimates put it at around 5 kilometers high. Other estimates have reached as high as 20. For comparison, Mount Everest is about 8.8 kilometers high. If the larger estimate is correct, this cliff could tower more than twice as high as Everest. And because Miranda's gravity is so weak, a fall from the top could take several minutes. Think about that. A tiny moon with a cliff potentially taller than the tallest mountain on Earth. And we don't even know exactly how tall it is, because we have only seen it properly once. Voyager 2 launched in 1977. It took nearly 9 years to reach Uranus, and on January 24, 1986, after traveling billions of kilometers, it finally arrived. But Voyager wasn't going to orbit Uranus. It wasn't going to spend years studying the planet. It had one chance. A few hours, cameras pointed at a world humanity had barely seen, and then it was gone. Imagine spending almost a decade traveling across the solar system, reaching one of its strangest planets, and having only a few hours to ask questions. What is happening inside it? Why is it tilted? Why is it so cold? How did its moons form? What is creating that bizarre magnetic field? What lies beneath those clouds? And perhaps most importantly, what have we missed? Jupiter has been studied by multiple spacecraft. Saturn was explored for years by Cassini. Mars has had orbiters, landers, and rovers crawling across its surface. But Uranus? One flyby. And that's bigger than just Uranus, because Uranus belongs to a category called the ice giants. And these worlds may be incredibly important for understanding planets both inside and outside our solar system. Yet we've barely studied them up close. There could be countless worlds in the galaxy with similar compositions, similar atmospheres, similar interiors, similar strange magnetic fields. And we've had one close look. One. For a few hours. So perhaps the biggest mystery surrounding Uranus isn't something on the planet. It's the fact that we haven't gone back. But that could change. Uranus has been identified as the highest priority destination for a future NASA flagship planetary mission, with concepts involving an orbiter and an atmospheric probe. And that's important, because when we eventually return, we won't just fly past. We could orbit. We could study its atmosphere. We could investigate its magnetic field. We could examine its rings. We could study its moons. And for the first time, we could spend years around the planet that we've only ever watched for hours. And maybe we'll finally discover why Uranus ended up this way. For nearly 250 years, we've watched Uranus from a distance. We've seen its strange tilt. We've measured its impossible cold. We've discovered its dark rings. We've photographed a moon that looks shattered. And we've listened to a magnetic field that behaves unlike almost anything else in the solar system. But almost everything we know comes from one brief encounter, one spacecraft, one flyby, one afternoon, nearly 40 years ago. And somewhere beyond Saturn, Uranus is still there, still rolling through the darkness, still carrying secrets beneath its clouds, still surrounded by worlds we've barely seen. Maybe the planet isn't breaking the rules. Maybe we just haven't learned the rules yet.